Good day, students. Welcome to another GeoGebra class. So in this particular class, we want to look at a couple of things. So the first one is we're going to look at how to construct some figures, most especially kites. So the previous videos, we looked at how to construct triangles, we know how to construct polygons, and we want to see how to construct a shape like a kite. So we're going to look at that. Then the next thing we would like to look at is what the theorem that says that when you draw tangents from a point, okay, two tangents from a point to touch a circle, those two tangents are congruent or they are the same. So we look at that theorem as well. All right. So we have our GeoGebra worksheet over here. Okay, and then we also look at some translations as well, mid rotation or in reflection. We look at those ones too as well. So let's start with the construction of a kite. So like every construction, we'll be needing lines and then circles to help us get the appropriate measurements and everything. So since we are constructing a kite, let's just put a line segment. So let's create a line segment here. Okay. Now, since we are constructing a kite, I'm going to put a perpendicular line. So first, let me put a point on this segment. So let me put a point somewhere here. Then I'll use my perpendicular tool. So perpendicular line to get a line perpendicular to this at this point. Then I can use my circle with center through point. Then I want the center at C. Then I'll increase it somewhere. Anywhere is fine. Okay, so I can put my circle to maybe here. It's fine. Then I'll find the point of intersection. So this one I want to use my two input field to find the intersection of the two objects. So the first one is the circle, which is represented by small c. Then the second object is my perpendicular line, which is represented by um, G. So this is the perpendicular line represented by G. So these are my 2 points of intersection. So I have E here and then F. So I can remove my line, okay, and my circle as well. So now I can use line segments. So let me use the tools up here. Can go to segments and then connect this to that to A, then also connect E to B, connect A to F, and then F to B. Okay, so we have our kite here. So the first part, which is construction of a kite, we have it done. Okay, so we've constructed a kite, and you can always check the angles in the kite we have constructed here. Okay, so you can remove the line segment that we created, the F, and you can also take off the C point. And then we have this over here. So our circle, the length of our circle, because of the radius of the circle, that's why the kite is useful. So you can change the radius of the circle and get different kites. Okay, and the kite will be different. So you have to understand the definition of kite so that when you're drawing it, you know what to do. So to check the angles, the interior angles, you can just come to angle, but first you have to use the polygon to wrap it up. And then now you can use the angle to check the angles inside. And the sum of all these angles should be equal to 360. So when you have any quadrilateral four-sided figure, the sum of all the angles in it should be equal to 360 degrees. All right, so that is how you can construct a kite by using just lines and circles to get a kite. So this line um should be equal to this, and this is also equal to that. That's the definition of a kite. So you see here in my algebra view, you can see that B is equal to F1. Okay, so this is B and this is F1. So this is equal to this. And then this one, this side too must be equal to this side. So let me, so that we can see things clearly. So E must also be equal to A. So that's it over here. E, the length of E is 2.7, the length of A is 2.7. So this is the criteria for it to be a kite. This side must be equal to this side, and this side must be equal to this side. So since we have that B is equal to F1 and E is equal to A, we can call this a kite. So you can try that too, and then you'll be able to do it. All right. So the next thing we want to do is look at when you draw two tangents from a point to touch to a circle, to touch a circle. So because we are using point and circle, we can first start with our circle. So I'm going to put a circle somewhere here. So this is my circle over here. Then let's put a point somewhere here. Okay. So if we want to do some animations for it, then we can first put a line or a line segment here, let the point move on it. So I'll be doing that so that we can add some animations. So I'll first put a line segment here. And then I'm going to put a point on that line segment. So point. So let me use the toolbar here. So go to points, then click the line or the line. This is the line segment. So click on the line segment and you put a point on it. Then we can hide everything. So we can hide the line segments, except the points that we put on the line segments. Then we can hide H as well. We don't need H. Then we can use our tangents tool. So tangents, then we click on the point and then the circle, and then it will create two tangents, okay? It will create two tangents. So from this point, we can have two tangents, and exactly two tangents. We cannot have more than two. So one of the tangents is going to intersect the circle somewhere here. The other one will intersect the circle somewhere here. Now let's find the points of intersection. So let's go to our intersect tool. So intersect, and then let's click on the circle, then the first tangent, then the circle again, and then the other tangent. We get these 2 points of intersection. Now, we can use line segments here to join this point of intersection to the center here, then from the center to also this point of intersection. Okay. Now, we can come to angles and find the angle, find the angle here. Okay, so let's see. So this angle is currently 136. Then let's check the bigger ones we see. So the angle formed here, let's check the value of that angle as well. So click on the angle 2, then angle MKL, 43.83. So these are the two angles here in the algebra view down here. Okay, so what we want to do is we want to find the sum of the angles. Okay, so this is all part of the theorem. So the first angle is called epsilon. So epsilon plus, and then the other one as well. That's this symbol. And when I hit equal to, you see that it's equal to 180. So the theorem is saying that from a point, you can draw two tangent lines to touch any circle. From any point, you can draw at any point that is not on the circle. You can draw two tangents from that point to touch any part of this, to touch the circle. Okay. And those two lines will be equal. Equal in the sense that if this tangent, okay, so if you let this tangent move around the circle, you can move it up to the point where it will come and lie exactly on this line. So this line here can be moved down, and then it will come and lie exactly on this line, passing through this point here, L, and the point here, K. Okay, it is possible. So that is why we are saying these two lines are equal. And you can say something also about the angle that will be formed from here. That is the angle at the center here by the points of intersection of these two tangents, and then the angle here by the points where the points where the two tangents are passing through. the sum of those two angles will always be equal to 180 degrees. So to change the position of this point so that you can see that regardless of the position and the angles changing, the sum of the two angles will always be 180 degrees. Over here in the algebra view, we can turn the animation on because of the way we created this point. We can animate it. Now you can see that the two angles are changing. Okay, currently 138, 139. So they are changing. But the sum of the two angles remain 180 degrees regardless of the change. Okay, it will remain 180 degrees regardless of the change. Okay, so this is the theorem. So the theorem is saying that two tangents can be drawn from an external point to touch the circle. Those two tangents will be the same. And the interior angle. Okay, so you see this shape here almost looks like a kite, doesn't it? It looks like a kite. Okay, this kite that we draw, when you look here, you see like almost like a kite. And you can even say it is a kite. Okay, so it looks like a kite. To prove that it is a kite, we must make sure the length here. So let me pause the animation and let's know that the line here and here must be the same, because the definition of a kite says that these two lines must be equal, and then these two sides must also be equal. So here and here are definitely equal because this is a circle. And from the center to the circumference of the circle is what we call the radius. And the radius is equal at any point on the circumference. It's equidistance. So these two lines are definitely equal. So the issue now is with these two. So we can verify also whether they are equal by using the polygon tool. So we can just use the polygon tool to wrap it up and then see. So if you use the polygon tool to wrap it up, okay, so K1 and M1, which is created down here. So K1 is 6.54 and M1 is also 6.54. So you can see they are equal. And then the other part, which is this part and this part, 2.61, 2.61, which is the radius of the circle. Okay, so a kite will be formed whenever you have a shape like this. When you draw two tangents to touch, passing through a point to touch any circle, you have a kite formed, and the interior angle, the angles opposite each other will sum up to 180 degrees. I hope this makes sense. So this is the proof of the theorem. All right. So the last thing we want to do is to show rotation of any object. Okay. So rotation of an object. Let's go to circle. Okay. So the center of the circle will be the point of rotation. So the point of rotation will be the center of the circle. So let's say we wanted the circle somewhere here, and then this far. Okay, so let's remove the last point. Okay, let's not show point O. So this is the circle, and this point here, N, is the where we are going to do the rotation from. So what we want to do is to create a line or a tangent. So we want to create a tangent. So okay, let's bring back the point O, and that will be where the tangent will be. So the tangent here, then after creating a tangent, we are going to use line segment. So let me use points rather to put 2 points on this line. And then I'm going to use line segment to connect these 2 points. Then now I can remove the line. I can remove the line. I don't need points P and Q. And then I can put a point. Yeah. Okay, um so I'm going to draw a triangle. Using some points on this line segment that I created. And I'm using the line segments because the line segments, intersect this circle here at one point somewhere here. Okay. So I've drawn this triangle. So this triangle is what we are going to use to rotate around this point. So to create some animations for it, I'm going to use a slider. Okay. And I'm going to choose angle here. So theta, then 0 to 360 degrees. So we are doing it we are rotating it all the way. Okay, so if I turn there, and okay, so then I have to go to rotate about a point. Okay, so rotate about a point allows me to rotate around points. So I'm going to rotate this triangle around the center of this circle, and the angle of rotation will be theta, so that I can add the animation. So theta will be theta. So counterclockwise or clockwise, any way you want to go. So okay, now if I turn my animations on, okay, so you see that this triangle here is being rotated. So let me remove the line segments that I created. Okay, so we can see that this is being rotated. You can even remove the circle. Let's see what happens when you remove the circle. And you see it is rotating around this point. Okay, going this way and then back. Okay, so this is one of translations, rotation. Okay. So based on the question is to rotate maybe a particular triangle 180 degrees about the origin or about a point. If that point will be the center for the circle, or if it's the origin, then the origin will be the center of the circle. Then you just open the circle to a particular radius, draw your triangle such that it's a tangent to the base of the triangle, is a tangent to the circle. So usually they'll give you some points, okay? They'll give you some points and then you'll use that point to draw your triangle. Then you'll be able to rotate around the point. The circle may not be necessary. You can just create this point and then use rotate about a point to do the rotation. So we are going to actually take a particular question and then solve it later, but not in this video. In another video, we'll take questions on rotation and solve it. So for now, this is all we are going to be doing. So we've tried how to do a kite, how to draw a kite. We've also looked at the theorem which says that two tangents passing through a point, two tangents of a circle passing through the same point are congruent, and they will form a kite, and the angles opposite the angles vertically opposite will be equal, or will sum up to 180 degrees. Sorry, will sum up to 180 degrees. And then look at how to draw rotation. All right, so thank you very much, and we'll meet in another video. Thank you.